Yeah.
Hey, all right, we're back at Garrett's house the next day after our virtual field trip, and we went up and collected these soils, and now we're back and we're going to do a little characterization here at home. Very common, you know, you go collect soils, maybe you're running up against the clock, you want to get that last pit in, so you just collect the samples, take them back to your office, and characterize them. And we have Garrett's awesome peaches here from his backyard, so he lives it. He's growing food in his soils here, and so we're going to sieve some soils, and Garrett's going to show you a little bit about calculating gravel content and things like that. So thanks, Garrett.
Yeah, so you know, there's no substitution for experience, and like Stuart said, I think the best idea sometimes is not to be in a hurry to fill out the whole sheet in the field. Give yourself some time to process, take a day, think about it, and have your stuff. Come find a good spot in the shade, get yourself some ice water, and relax and think about what you did. This soil characterization is not a one-off process. Often you get trained, you got to get all that information that day and get it done. But once you have the samples, as long as you captured everything in the field that you have to, you can do everything else here. Color, texture. Often if you get the right samples, you can do structural units, things like that. So, you know, so many of the things on the sheet are semi-quantitative, qualitative, or quantitative in the sense of length and things like that. So every chance you can to try to standardize and create some level of standardization on measurements, it's great. So from my experiences working in soil survey, we started using a 2-quart cup to take the volume of soil that we're going to sieve, and then we can separate out the gravel content from that standardized volume. So we're going to be working with the surface or the basement, the bottom soil out of the second pit yesterday. No aggregates. We don't have to worry about trying to be nice and pick through the aggregates because it was pretty unaggregated on its own. And I'm really just going to take out a nice healthy cup of soil and start working it. There's some small rocks or large gravel in there, so that all counts, right? You don't want to over or underestimate if possible. So I'm going to take that one right out, and I'm just going to start sieving these soils and seeing what happens. And that would be a cut right there. That'd be a cut right there. Yeah. Because then it's like boom, and then.
So we've sieved the bottom and second from the bottom horizons from our second pit on our virtual field tour of the andesitic lahar materials here. And so right now we're doing our sieving so we can do texture and pH. And one of the most important parts of sieving is getting an estimate of gravel content. So gravel content, super important for things like water holding capacity.
What's gravel? What's a gravel versus fine fraction again? What's the break in those?
Anything greater than 2 millimeters is a coarse fragment. And then there's these breakdowns between gravels and cobbles and stones that are in the red book. I can't remember what it is, like 75 centimeters.
Go ahead, I'll pull it out.
2 to 75 is gravel. And then 75 to 250 is
Keep going and I'll
cobble.
It out.
All right, now I'm curious if I got it right or not. But
keep going and I'll get there.
So what we want to do is make an estimate of gravel content from the sieve. So anything that didn't pass through the sieve is a gravel. And in order to why it's useful to do this gravel content is for things like water holding capacity. So I remember I was working with a consultant in vineyards in Napa, and he said to me, we were in a pit, and he's like, you know, we really need to step up our gravel game, you know, because the water holding capacity, the amount of gravels is going to determine your root stock and your water holding capacity and your irrigation and things like that. So if you're out in a pit and you're characterizing it for something like a vineyard, it's really important that you know what the gravel content is, because that really skews the water holding capacity, which then is your interpretations for irrigation, for root stocks, whether you're in wine grapes or you know, almonds or walnuts or trees or whatever you're in. So let's do that really quick. Gary, you had something.
Yeah,
about...
just real quick. So 2 to 76 millimeters is gravel. 76 to 250 millimeters is considered cobbles. Stones are 250 to 600 millimeters, and boulders are anything greater than 600 millimeters.
So, Dr. Lyles, I was 2 to 75, so I was off by 1. Is that partial credit or do
in my class, that's still full credit.
Okay, good. All right. All right, so what we want to do is do this sort of semi-quantitative estimate of gravel content. So we sieve these in these turkey tins, and what I'm going to do is make a pile of the gravels. Let's prop this up a little bit so we get it a little bit flatter. All right, so we're going to take our gravels out, anything larger than 2 millimeters. we're gonna make a little pile. Time lapse. We should have had this out already. It's hard to get this out of the corner. Okay, so we get in our estimated gravel content, and so the first thing we did is we knocked out all of our gravels here. Normally you take those out of the top of the sieve. And what we're going to do then is sort of make these equally sized piles, right? Because we're trying to get the semi-quantitative estimate as a percent. So what I'll do here is kind of try and make a pile that's about the same size as that pile of gravel. So I'm going to say that's roughly the same size. That one's roughly the same size, and then we got a little bit of extra. So about, that would be, if it was 33%, 33%, 33%, then
Probably a fair estimate.
Then it would be about 33% gravel. So if I got a little bit more, maybe I'll call it 30% gravel.
And that pile might be a little bigger than your fine fraction piles when you really think about it. So that's probably, I would go with 2/3.
Well, but then you've got all the interstitial space there. This pack's tighter, you know. But yeah, let's call it thirds. I think thirds is fair.
You're haggling over semi-quantitative things, you know, at that point. So, you know, do your best estimate, but just remember that
You got to call it, and I'm calling it at 33.
Yep.
So second horizon from the top, 33% gravel. This is a way to do the semi-quantitative estimate of gravel. Knock out the gravels, then make piles that are around the same size.
One thing one basic thing to bring out of this that can't be overestimated is every place that you can standardize and make your process consistent across all measurements and across all examples, it's the best. So whichever way you go, figure out what's best for you, and always be looking to make things more efficient, more standardized, better. Just because you learned one way doesn't mean that's the best way to do it each time. So I did it with the turkey pan. Honestly, in the field and most applications, the sharpshooter is really a good way to do it because the way that it lays out. As you just saw with Stuart's ability to get the material out of the pan, it's really easy to push the soil off of the sharpshooter into your hand to do the texturing component of it. But here I got the same idea. I'm gonna go with, you know, my guess would be probably 60-40, maybe 50-50, right? Depends on what you think about it. These ones, if we got out the tape measure or the book, we would be able to see that. I think this has the scale in it, doesn't it? Or it's on the outside. So see how big this is, right? This one's weighing in on the long axis at about 85. So I probably would be able to take this one and throw it into that stone category. These ones probably are going to still fall within the cobbles. So everything from coarse to fine, or gravel, sorry, these are cobbles, pardon me. Coarse to fine on the gravels, one cobble, and then the rest of the fine fraction material. Removing the cobble, which we had in the infield estimate, I definitely think I'm going to go 60% fine fraction, 40% gravel in my estimate.
Garrett, can you remind me, you measured that on the long axis. Is it the long or short axis that is the indicator?
That's a really good question. I mean, because it is about will it fall through a sieve. It depends on the way that you separate them. I went long axis just to represent that there are two. I don't really have a good rule on that one, so we'll have to get back to you on that one.
There's a real rule.
I'm sure there is. I just don't know it.
I thought it was a short
It
axis.
is? Okay.
Yeah.
Well, then that one
But
falls.
I don't remember.
That one clearly falls into the coarse gravel, right? If that's the case. So.
I was hoping you knew because I didn't remember.
No.
Yeah.
I just wanted to show. I mean, We just took a break to check out to see what the rule was to set up what was the length or dimension to measure to either include or exclude in a category. And so Stuart looked at the mauve book to see what was going on.
Yeah, we've got the plum book here as far as color, and looking at it, and
so are all gravels and cobbles the same on shape, or are there
yeah? So
subcategories?
I'm on page 247, and it's saying that if it's shape, spherical or cube-like, then you do it by diameter.
So that's not the case. This is not spherical or cube-like.
Your classic like river gravel, right? Yeah. Then it's by diameter. And if the shape is flat, like prismoidal or subprismoidal, So
that's the case.
channers, things like that. Then it has an entirely different breaking out system, and it's based on the long axis.
Woo! Yeah, I was right, even though I didn't know.
So then that would actually be a flagstone, and from 150 to 380 millimeters long is flaggy. So for the sake of this pit, we're gonna call it a gravel. But if you really wanted to get into it, or we'll call it a cobble. But if you really wanted to get into it, you could break them down into if they're flat stones into flagstones, channers. And
So
things like that.
another quick note on your field sheet. Look at Kitty trying to get in your stuff. Kitty's trying to texture. Kitty's trying to texture.
Did you get it at all?
Kitty was totally texturing.
Let's see, she'll do it again.
Kitty's coming.
Go for it, Kitty. So remember, we're talking about trying to characterize the soil across all these different factors, and we have this field sheet that is a record of all those things. And this would be a great example of a place where you would just want to make a note. You want to make a note of the shape and the size. If there was a question, or if someone else is going to look at this information later, you clearly recorded that these were not round, which helps you with what additional piece of information. Rounded materials usually infer alluvial processes in water, where this one is clearly not rounded, so you can start to exclude that idea that this was deposited by water.
The cats are really into our soil here. Anyways, he jumped out.
So be a cat and be into soil.
Hey, all you cool cats and kittens.
That
Okay, so this is the second from the top on the second pit, doing the gravel estimate. I'm going to say it's less than 33% based on these three piles. So I'm going to go, let's go 28%. A little bit less than a third. Okay, that's it.
for which horizon?
For the second, this is for the second from the top of the second pit.
Okay.
So that kind of more weakly developed, higher elevation soil on that andesitic lahar material. So less than a third, but more than a quarter. Let's call it 28%.
Okay. Cool.
Second, this is for the second from the top of the second pit.
Okay.
So that kind of more weakly developed, higher elevation soil on that andesitic lahar material. So less than a third, but more than a quarter. Let's call it 28%.
Okay.